A mysterious visitor from deep space named 3I Atlas is racing through our solar system, and it's not behaving as scientists expected. Its strange brightening and shifting tail may hold clues we've never seen before. In this video, we'll uncover the secrets now beginning to emerge. If you enjoy cosmic mysteries, please like, subscribe, and share, and tell us in the comments, what do you think 3I Atlas really is? Thank you for joining us. Now, let's begin. In the early days of July 2025, a faint signal drifts across the data streams of automated sky surveys. It is not unusual for telescopes designed to patrol the night sky to capture new specks of light. For the heavens are filled with comets and asteroids crossing their endless paths. Yet this object is different. Its motion through the star field is faster than what a body bound to the sun would normally display. Careful analysis reveals it is approaching from the direction of the constellation Libra, moving with a velocity close to 60 kilometers per second, a speed that exceeds the escape threshold of the solar system. That single clue identifies it as an interstellar traveler, an emissary from beyond the sun's domain now catalogued as 3I Atlas, the third confirmed interstellar object known to humankind. The announcement spreads quickly through the astronomical community. Memories return of two previous visitors first, ʻOumuamua in 2017, then Borisov in 2019. Both carried mysteries that remain unsolved, one behaving like a rocky shard with no cometary halo, the other like a comet but with subtle differences in composition. Now, less than a decade later, a third messenger has arrived, and its timing adds urgency, for it is already racing inward, destined to reach the inner solar system within months. Astronomers begin to mobilize telescopes across the Earth, and in orbit planning for the narrow windows of opportunity before the sun's glare will swallow the view. At first, the observations are faint, the object presenting itself as a dim patch, requiring long exposures and careful stacking of images. Early estimates suggest it carries a nucleus of modest size, yet around it forms a diffuse haze of gas and dust, the coma that reveals sublimation of ices. The fact that this activity is visible even while still at the distance of Jupiter is puzzling. Ordinary comets that originate in the outer solar system often remain dormant until much closer to the sun, for the solar warmth at such distance is feeble. The early awakening of 3I Atlas suggests volatile compounds within its structure are more sensitive, perhaps preserved through eons of interstellar travel, and now liberated with startling efficiency. As July turns to August, the pace of change accelerates. Amateur astronomers armed with sensitive detectors and wide-field optics begin to notice that the coma is not only expanding, but doing so at a rate faster than models predict. Reports accumulate of unexpected brightening sudden leaps in magnitude that cannot be reconciled with the smooth curve expected from increasing solar proximity. Professional observatories attempt to track the anomaly, though time on the largest telescopes is scarce. Still, the mounting evidence is difficult to dismiss. Something unusual is unfolding, and the object seems unwilling to conform to precedent. The question arises whether the light increase stems from instrumental effects, or whether the nucleus itself is undergoing bursts of activity. If small jets erupt from beneath its crust, they could temporarily increase brightness. If the surface layers fracture under thermal stress, fresh material might vaporize in sudden flashes. Yet the pattern of changes does not align neatly with such explanations. Instead, it suggests a deeper complexity within the body, a set of processes unfamiliar to the comets known from the solar system. The orbital calculations refine as more observations are fed into computers. The trajectory confirms that 3I Atlas is not captured but will pass through only once. Its path will swing it close to Mars in early October, then curve nearer to the Sun at the end of that month, before flinging it outward again toward the galactic dark. Each milestone is an opportunity, yet each is fleeting, for within weeks it will vanish beyond reach. The sense of urgency grows. Instruments aboard spacecraft already in orbit around Mars are prepared to point their sensors, hoping to glean data during the flyby. On Earth, observers brace for the coming superior conjunction, when the Sun will hide it from view around the 21st of October. The clock is ticking, and every night of clear sky becomes precious. During these first months of discovery, speculation begins to sprout around the edges of the data. The peculiarities are noted in quiet conversations between astronomers, then echoed more widely in public forums. Could this body be unlike any comet or asteroid known? Might it represent debris from a shattered planet in a distant system, or perhaps an exotic mixture of compounds never seen before? The fact that its light curve does not follow expectations makes the comparisons with ʻOumuamua and Borisov inevitable. Each of the three interstellar visitors has displayed unique and baffling features, as though no single category can hold them. The notion arises that interstellar space delivers to us samples of extraordinary variety objects shaped by conditions alien to our own solar system, bearing chemical signatures from stars scattered across the galaxy. Meanwhile, the comet continues its rush inward, its speed immense, its direction steady. To imagine the scale of its journey is to step into the incomprehensible. If it originated in a distant stellar nursery, it may have been wandering for hundreds of millions of years, perhaps longer than complex life has existed on Earth. Through all that time, it has been bombarded by cosmic rays shaped by encounters with tenuous clouds of gas weathered by micrometeoroid impacts in the deep interstellar void. Its surface may carry scars of that ancient voyage, layers of chemistry altered in ways no laboratory can yet reproduce. Now by chance it crosses our system, offering a brief encounter before continuing its pilgrimage. In the stillness of astronomical charts, the numbers seem clinical, but behind them lies wonder. A body the size of a mountain, moving faster than the speed of escape, awakened by the touch of sunlight it has not felt for ages, glowing faintly green, expanding its veil of gas and dust like a lantern carried into the solar system. The detection of 3i Atlas is more than another point in a catalogue. It is an unfolding story of how the universe occasionally allows us to glimpse fragments from beyond. Observers in July may not yet realize how strange this one will prove to be, but the seeds of mystery are already planted, and the weeks to come will draw them into focus. The first section of its story is written in the lines of orbital equations and faint photographic streaks, but the true depth of its enigma is only beginning to reveal itself. As the days of August unfold, 3i Atlas continues its plunge toward the inner solar system, and already it shows behavior that unsettles familiar expectations. At a distance, where icy bodies from our own Oort cloud often remain dormant, this interstellar wanderer is already alive with activity. Its coma swells outward, a tenuous shroud of gas and dust that reflects faint sunlight and signals sublimation beneath the surface. The growth of this envelope is rapid, far faster than cometary physics would ordinarily allow, as though hidden reservoirs of volatile compounds are being tapped all at once. Observers who track the object nightly find themselves confronted with sudden leaps in brightness, not the smooth and gradual increase that theory predicts. On certain nights in mid-August, the apparent magnitude rises steeply, then steadies only to surge again days later. Such behavior ignites debate among astronomers who pore over the data, comparing measurements from different instruments and apertures, wondering whether technical artifacts might be distorting the view. Yet the consistency across multiple independent reports suggests the effect is real. What seems to be happening is that 3I Atlas is venting in ways unseen before, perhaps triggered by internal fractures that split open under the strain of solar heating. More curious still is the evidence of early activity when it was even farther from the Sun, back near the distance of Jupiter's orbit. Archival imaging from sky surveys reveals faint traces of coma long before it should have been possible, as though the object were predisposed to awaken under weaker radiation. This discovery pushes speculation into new territory. Perhaps its crust contains compounds so volatile that even distant sunlight can stir them into gas. Perhaps its exposure to cosmic radiation during its interstellar voyage altered its chemistry, creating unstable mixtures that erupt suddenly when warmed. Whatever the cause, the timing of this activity sets it apart from solar system, comets aligning it more with a category yet to be named. In these weeks, amateur astronomers play a central role. Wide-field instruments stationed under dark skies capture images that professionals alone cannot provide, filling in the gaps left by limited access to large observatories. These enthusiasts report not only the brightening but subtle changes in the shape of the coma, noting asymmetries that hint at directional jets or uneven sublimation. Through forums and shared databases, they exchange raw frames and processed composites, piecing together a portrait of a body that refuses to follow convention. Their contribution is more than supplemental. It becomes essential, for the professional community acknowledges that without this collective vigilance, many details would slip away unnoticed. Professional facilities do contribute critical insights. Spectrographs mounted on mid-sized telescopes begin to detect unusual signatures in the light scattered from the coma. Early spectra suggest the presence of carbon compounds, but the intensity is puzzling. There are faint hints of diatomic carbon, the molecule that can give comets a green glow when excited by sunlight, but the proportions are inconsistent with what would normally appear at this stage of approach. It is as if the chemical inventory is rearranging itself in real time, shaped by reactions unfamiliar to solar system experience. This strangeness will become more pronounced in September, but even now the seeds of that enigma are visible in the data. The global astronomical community takes note of how quickly events are unfolding. Within weeks of discovery, 3I Atlas has become not just a curiosity, but a subject of coordinated observation campaigns. Proposals are filed for telescope time on instruments capable of high-resolution imaging from the Hubble Space Telescope to the James Webb Space Telescope. Yet there is a challenge. The object's trajectory places it increasingly close to the Sun from Earth perspective, and windows for observation shrink as it slides into daylight glare. Astronomers know that by October it will be lost for weeks, in conjunction invisible against the brilliance of the Sun. Every remaining opportunity matters, for after that interval perihelion will arrive swiftly, and the story may already be written by then. What makes the unfolding anomaly so compelling is the speed with which the object evolves. At 60 kilometers per second, its motion relative to the Sun is relentless. It does not linger in the outer system for years as ordinary comets do. Instead, it compresses stages of activity into weeks, forcing astronomers to adapt. Processes that would normally stretch across months are witnessed in rapid sequence, like a film running at accelerated speed. This compression adds urgency to each observation and magnifies the difficulty of interpretation, for models built to describe slower moving comets cannot simply be scaled to match. 3I Atlas is not just fast, it is different. Discussions begin to circulate about the possibility of fragmentation. Some observers note that sudden brightening could correspond to pieces breaking away, exposing fresh surfaces. Others caution that no direct evidence of fragmentation has been seen. The coma remains diffuse but intact without obvious trailing debris fields. Yet the idea lingers, for the history of comets within the solar system is filled with cases where bodies fractured as they neared the Sun, torn apart by tidal stress or internal pressure. If 3I Atlas carries internal weaknesses born of its long interstellar journey, it may be prone to such disintegration. If so, then its story might end before perihelion, leaving only clouds of dust to mark its passage. Beyond the technical debates, there is a sense of wonder at what it represents. Here is a fragment from elsewhere carrying within it the memory of a distant system crossing our path for a brief season. The material that now outgasses into its coma may once have condensed around another star in a protoplanetary disk where planets formed and perhaps life arose. The atoms released into the solar system may have been trapped in ice for billions of years, shielded in the dark between stars until now. Each photon they reflect is a message from an origin we may never identify. To study this body is to glimpse beyond the boundary of our own system, to touch the chemistry of a place we cannot yet visit. By the close of August, the object has already drawn the attention of agencies beyond academia. NASA, ESA, and other organizations quietly monitor the growing stream of data, considering whether any spacecraft in operation might capture meaningful observations. While no mission can intercept it directly, instruments aboard probes orbiting Mars and elsewhere may record valuable measurements during its passage. Plans begin to align around the October 3rd flyby of Mars, when orbiters equipped with cameras and spectrometers will have a rare vantage point. The anticipation of that event casts a long shadow forward, for it promises data of a kind impossible to obtain from Earth. Through these early weeks, the narrative of 3I Atlas becomes layered with contradictions. It is brightening faster than expected, yet still invisible to the naked eye. It is active earlier than theory allows, yet does not display the orderly tail of a typical comet. It seems both fragile and vigorous, unstable, yet persistent. Each new measurement raises more questions than it answers. This is the hallmark of a genuine mystery, an unfolding puzzle that resists the categories designed to contain it. And in this refusal to fit it, compels observers to keep watching, to keep asking, to keep wondering what secrets it carries on its impossible journey. By the time September begins, 3I Atlas has passed a threshold that seems to transform its behavior. At a distance of roughly 2 astronomical units from the Sun, where Earth would appear half as far again, the interstellar visitor responds with a surge of activity more dramatic than anything seen before. Observers around the world record a sudden leap in brightness, the apparent magnitude shifting by full steps in only days, each step representing not a simple increment, but a multiplication of light by factors of more than 2. What should have been a gradual curve of increasing brightness smoothed by distance, and the predictability of solar heating, instead bends sharply upward, as though the body is accelerating in its response to the Sun. Astronomers describe this in terms of a deviating light curve, a simple graph that tells a far more complex story. The line of prediction had been drawn based on models of known comets, assuming that as the Sun's energy increased, the sublimation of ices would track in proportion. But now data points plotted from nightly measurements scatter away from the line, rising higher and faster than the model allows. Debate erupts about whether these changes are intrinsic to the body or artifacts of observation. Amateur astronomers using smaller instruments report consistent brightening, while larger telescopes with more sensitive detectors confirm the trend. The weight of evidence leans toward reality, not illusion. Something is happening deep inside 3I Atlas that standard cometary theory cannot contain. The expansion of the coma is the most visible sign of this new phase. Once modest, it now swells outward, until in relative terms it rivals the apparent size of the Sun when measured from Earth. Instruments detect that the gaseous envelope stretches to millions of kilometers across, filled with dust and molecules streaming away from the nucleus. This immense halo, faint but measurable, transforms the object into a diffuse sphere larger than planets, though so tenuous that it would vanish if spread into the vacuum of a laboratory chamber. The sheer scale of the coma astonishes those who calculate it. To imagine a body perhaps only a few kilometers in size generating a halo half the width of the Sun is to appreciate the strange efficiency of sublimation under the influence of interstellar chemistry. The appearance of colour intensifies the sense of anomaly. Reports emerge of a distinct green hue glowing from the coma captured in long exposure images, where stars streak in the background and the interstellar object alone remains fixed. The glow is consistent with the presence of diatomic carbon, a molecule known to fluoresce when energized by ultraviolet sunlight, yet earlier data had suggested that 3I Atlas did not contain such compounds in abundance. If it is now producing them in quantity, then chemical transformations must be unfolding within its structure. Perhaps heating has reached layers where these molecules are locked, or perhaps reactions triggered by radiation are generating them anew. In either case, the glow adds a visual marker to the mystery, a sign that this visitor carries within it the seeds of chemistry unfamiliar to our system. The sunward orientation of its activity deepens the enigma further. Ordinarily, comets display tails that extend away from the Sun, driven by the pressure of solar wind and radiation. Dust and ions are pushed outward, creating streams that trail behind the body as it moves along its orbit. But images of 3I Atlas show something different, a structure that points not away but toward the Sun, a feature astronomers call an anti-tail. This peculiar geometry can sometimes occur when perspective aligns dust along the orbital plane, but in the case of 3I Atlas, the effect is unusually pronounced and persistent. Instead of a graceful tail stretching into darkness, the object seems to resist expectations, projecting material in the opposite direction. It is as if the Sun's influence is being answered in a way that does not obey the familiar rules of plasma dynamics. To describe these observations, astronomers draw upon the language of dusty plasma, a term that refers to the mixture of ionized gas and solid particles charged by radiation. In laboratories on Earth, dusty plasmas display complex behavior, forming filaments and structures that mimic biological patterns self-organizing in ways that seem to straddle the line between inert matter and something more. If 3 Atlas is truly manifesting such a plasma environment on a grand scale, then its coma becomes not just a haze of dust, but a dynamic system shaped by electromagnetic forces as much as by gravity and heat. The thought is unsettling, for it implies that the interstellar object may be a natural laboratory in motion, carrying with it processes that blur the boundaries between chemistry, physics, and perhaps something resembling order. The data flow accelerates during these weeks, with observatories racing to record as much as possible before the window closes. The Hubble Space Telescope secures time to attempt images despite the challenges of brightness and position, while the James Webb Space Telescope considers spectroscopic campaigns that could reveal precise molecular compositions. Ground-based observatories such as those in Chile and Hawaii join the effort coordinated by networks of astronomers determined to capture the fleeting presence of this cosmic visitor. Yet the clock is merciless. Superior conjunction with the Sun approaches in late October, when Earth, the Sun, and 3I Atlas will align in a way that hides the object entirely from view. The brightening that now draws attention may peak at precisely the moment when observation becomes impossible. The irony is bitter just as the mystery deepens, the ability to watch will be taken away. Amid the intensity of technical debate, a quieter current of speculation flows. Some scientists wonder aloud whether 3I Atlas might represent a category distinct from either comet or asteroid. Others ask whether the unexpected brightening is a prelude to fragmentation, as stress within the nucleus builds beyond endurance. If it disintegrates before perihelion, the chance to study it as a coherent body will be lost. If it survives, it may offer insight into materials preserved since the dawn of another star system. The stakes are high, for the difference between survival and disintegration may define whether humanity gains a lasting record of its nature or only transient dust clouds dispersed by solar wind. The public too becomes aware of the strangeness. News outlets pick up the story, emphasizing the rarity of an interstellar visitor and the possibility that it may glow brightly in coming weeks. Enthusiasts speculate on forums about the chances of seeing it with binoculars, though astronomers caution that even at its brightest it may remain a challenge to naked eye observation. The fascination lies not in spectacle, but in the science, the idea that for a brief span of time, humanity can witness the passage of a messenger from beyond the solar system. Every update carries the weight of history, for only 2 such objects have been seen before, and both left more questions than answers. As September draws to a close, 3I Atlas is no longer just a point of curiosity, but a central character in a drama of cosmic proportions. It has awakened early, brightened beyond prediction, and displayed a geometry that defies explanation. Its green glow signals chemical processes not fully understood, and its vast coma transforms it into a presence larger than imagination allows. It hurtles onward at 60 kilometers per second, inexorably approaching both Mars and the Sun, compressing into weeks the unfolding of mysteries that might otherwise stretch across years. Astronomers know they are witnessing something extraordinary, and though the data may be incomplete, the sense of wonder grows with each passing night. The secrets of 3I Atlas are beginning to surface, but they do so not with clarity but with questions, each anomaly leading deeper into the unknown. The peculiar brightening of 3I Atlas now dominates discussion across the astronomical community. The deviation from its predicted light curve has become impossible to ignore. Where calculations expected a slow and orderly rise in brightness, the object instead leaps upward in irregular surges, as though some hidden clock within its nucleus dictates sudden bursts of energy. To trace these changes, astronomers compile light curves from dozens of independent observers scattered across the globe. Amateur telescopes in quiet backyards, university observatories with modest instruments, and professional facilities with high-grade detectors all contribute points on the same plot. Together they reveal the same unsettling truth: the curve is broken, its line bent by unknown processes that act too quickly and too powerfully to be dismissed as error. Every leap in apparent magnitude corresponds to a release of light more than double the previous measure, building toward levels unimagined only weeks before. The cause is elusive. Some propose that the nucleus contains stratified layers with pockets of volatile compounds sealed beneath harder crusts. As heat from the sun penetrates deeper, it may strike these hidden reservoirs and release sudden jets of vapor and dust. Others argue that the speed of the object, nearly 60 kilometers per second, exaggerates sublimation, driving transitions faster than terrestrial models predict. Yet the magnitude of change remains difficult to reconcile. If sublimation alone is responsible, then 3 Atlas must be unusually rich in fragile compounds, perhaps preserved for eons in the cold of interstellar space. If not, then new mechanisms are at work, ones that no comet within the solar system has displayed. Spectral data sharpen the puzzle, Telescopes equipped with spectrographs dissect the faint light of the coma, splitting it into lines that betray chemical signatures. In early September, several groups report elevated levels of diatomic carbon molecules that fluoresce under solar ultraviolet radiation to produce a vivid green glow. The irony is that initial measurements weeks earlier had shown little sign of such compounds. Their sudden emergence suggests that either deeper layers have been exposed or that reactions within the coma are creating them anew. Neither explanation is entirely satisfying. If deeper layers were involved, the timing seems too abrupt. If new reactions are forming the molecules, the efficiency must be extraordinary, operating at scales far beyond those seen in typical comets. The result is the same, a glow that intensifies the mystery, casting the interstellar object in a shade of green that stands out against the black of space. The shape of the coma also refuses to conform. Rather than a smooth and symmetrical halo, images show irregularity with brighter regions suggesting localized jets. At times, faint extensions point sunward rather than away, forming the anomaly known as an anti-tail. In solar system comets, such structures can appear briefly when perspective aligns dust along the orbital plane, but here the effect is prolonged and clear. Dust and ions seem to be organizing themselves in ways that defy the push of solar wind. Plasma physicists take notice, suggesting that electromagnetic forces may be shaping the material more strongly than usual. If the coma has become a dusty plasma, a mixture of charged gas and solid grains, it may behave in complex ways, forming structures that mirror patterns of turbulence and self-organization. In laboratory experiments, dusty plasmas form filaments and vortices that seem almost alive. On the scale of millions of kilometers, 3I Atlas could be manifesting similar dynamics sculpted by forces invisible to the eye. The community of observers grows as news spreads. Forums dedicated to astronomy fill with updates, each new image compared against the last, each data point debated. Professionals join the discussion, careful to separate speculation from fact, but acknowledging that the object's behavior is genuinely unprecedented. The public is drawn into the story, fascinated by the idea of an interstellar visitor displaying such strangeness. Media reports highlight the rare chance to witness something beyond the solar system, though astronomers caution that visibility to the naked eye remains unlikely. Still, the green glow captured in long exposures captures imaginations, lending the object a spectral presence, as though it were a lantern carried into the solar system by unseen hands. The urgency of observation intensifies with the approach of October. Superior conjunction looms the alignment where Earth-Sun and 3I Atlas fall into a straight line, rendering the object invisible against the solar glare. Astronomers calculate that by the 21st of October, it will be fully lost from view, emerging only after perihelion has passed. The window is closing fast. Proposals for telescope time on Hubble and Webb are weighed against the difficulty of pointing near the Sun. Ground-based observatories seize every clear night. Even amateur astronomers push their equipment to the limit, seeking any opportunity to record the comet before it vanishes. The knowledge that a close approach to Mars awaits on the 3rd of October brings hope for orbiters. They are equipped with instruments capable of measurements impossible from Earth. For now, though, all eyes remain focused on the accelerating enigma. The strangeness of the light curve becomes symbolic of something larger. It is not simply a deviation, but a signal that this body does not belong to the categories shaped by solar system experience. ʻOumuamua, Borisov, and now 3I Atlas. Each of the three interstellar visitors has refused conformity. The first lacked a coma altogether, appearing as a tumbling shard that accelerated without visible exhaust. The second behaved more like a comet, but carried unusual dust grains and volatile abundances. The third glows green, expands a vast coma, and points its activity toward the Sun instead of away. Together they hint that the population of interstellar objects is not uniform, but wildly varied, shaped by processes in distant systems, and carried across the galaxy by chance and gravity. Speculation takes root in the gaps of knowledge. Could 3i Atlas be a fragment of a shattered planet hurled into space by ancient catastrophe? Might it be debris from a stellar nursery ejected before planets had time to form? Some wonder whether its plasma environment might interact with the solar system in ways yet unseen, stirring electromagnetic effects across space. A few voices even venture ideas of artificial origin, imagining that the precision of its path and the oddity of its emissions could mark technology rather than nature. Most scientists dismiss such thoughts, preferring explanations grounded in physics, but the speculation speaks to the sense of wonder the object inspires. When faced with phenomena that resist familiar models, imagination fills the void, reaching for possibilities beyond the known. In September, nights under clear skies, the object appears in long exposure images as a small but distinct patch, its greenish tinge evident, its coma expanded beyond expectation. Stars trail as streaks in stacked frames, while 3i Atlas stands still captured across minutes of exposure. Each image is a frozen fragment of a dynamic process, a brief glimpse of a body changing by the day as it rushes sunward. To those who follow its progress, the experience is one of watching, not just an object, but a mystery unfold. The brightening is not merely light, it is information encoded in photons that reveal both chemistry and dynamics. To interpret it is to try to read a language written by another star system, a script inscribed in dust and plasma. By the end of September, consensus forms around one conclusion. 3i Atlas is behaving in ways that no solar system comet has ever shown. Its light curve is disrupted, its chemistry evolving rapidly, its coma vast and oddly oriented. The deviations cannot be explained away as error or perspective. They are real, and they mark the interstellar visitor as something extraordinary. What lies ahead remains unknown. The close approach to Mars, the concealment in conjunction, and the perilous dive to perihelion all wait in the near future. For now the anomalous brightening stands as a beacon signalling that the secrets of 3i Atlas are beginning to surface, but in forms stranger and more elusive than anyone had expected. By the opening days of October 3rd, Atlas approaches the next stage in its accelerating drama. Its distance to Mars is shrinking rapidly, and calculations show that on the 3rd of October, it will pass at just a quarter of an astronomical unit from the red planet. For Earth-based observers, the significance of this encounter is immense, for it means that spacecraft already orbiting Mars can be directed to capture data unavailable from any terrestrial telescope. The Mars Reconnaissance Orbiter, the Trace Gas Orbiter and other orbiters in Martian skies adjust their instruments ready to seize the brief chance to measure brightness spectrum and perhaps even resolve details of the coma from closer range. For the first time in human history, a planet other than Earth becomes a forward outpost for interstellar observation, a listening post standing in the path of a traveller from another star. As anticipation builds, Earth-based astronomers push their telescopes to the limit. The comet's coma is now colossal, a sprawling envelope of gas that continues to expand. Its brightness remains unpredictable, surging upward on some nights, plateauing on others, but never settling into the smooth progression of a traditional comet. The green glow persists, baffling those who analyze the chemistry. Spectra confirm diatomic carbon, but in quantities too great to be explained by standard models. The suggestion grows that new chemistry is taking place within the coma itself as ultraviolet radiation breaks apart larger molecules and recombines them into new forms. If so, then 3i Atlas is not merely venting frozen ices, but actively processing them, transforming ancient compounds carried for untold millions of years in interstellar space. This makes the coma not just a reflection of the nucleus, but a laboratory where physics and chemistry dance on cosmic scales. Meanwhile, attention focuses on the orientation of its emissions. The anti-tail remains persistent, pointing toward the sun when all expectation insists it should stream away. Plasma physicists offer models in which charged dust grains respond not only to radiation pressure, but to the complex interplay of solar wind and interplanetary magnetic fields. In these models, the sun's influence bends rather than pushes, drawing dust into alignments that seem counterintuitive but arise naturally from electromagnetic structures. Yet even these explanations feel incomplete. The scale and persistence of the anti-tail suggest forces more organized than turbulence alone, as though the interstellar visitor carries a history of charge and structure that guides its response to the sun. The thought is both humbling and unsettling, perhaps. 3i Atlas brings with it a memory of plasma environments beyond the solar system, imprinted during its long voyage through galactic space. On October 3rd, as predicted, the flyby of Mars occurs. Data from orbiters is not immediately available, for signals must traverse millions of kilometers and be processed before results can be shared. Still, astronomers on Earth know that for those few hours, machines around another world were pointed at an alien comet, capturing photons that travelled across interplanetary space to reveal secrets no human eye has seen. The symbolism is striking. A planet once imagined only as a distant light now serves as a laboratory for studying an object from another star. Humanity's reach, limited as it is, has extended just far enough to intercept the fleeting path of a wanderer that has journeyed perhaps for 1 billion years. Back on Earth, observers note that visibility is becoming more difficult. The alignment of sun and object draws closer, and atmospheric scattering makes twilight observations increasingly faint. Still, a dedicated cadre of astronomers continue to track it night after night, their images stacked and processed to extract every photon of detail. Some capture faint hints of striation within the coma, as though filaments of plasma weave through the dust. Others report subtle changes in hue, the green glow sometimes tinged with faint blue or yellow. Each new feature sparks debate, but consensus is elusive. The comet remains a moving target in both space and interpretation, resisting firm conclusions as surely as it resists the sun's attempt to sculpt a traditional tail. Speculation grows in proportion to the anomalies. Some scientists suggest that the object's nucleus may be far larger than first estimated, hidden within the glare of its vast coma. If so, its mass would be immense, raising questions about how such a body could have been ejected from its parent system. Others propose that it may be unusually porous, a lattice of ice and dust riddled with voids that collapse as it nears the sun, releasing sudden floods of gas. A more radical idea is that it carries compounds unknown to our solar system exotic ices, formed under conditions around other stars. If these compounds sublimate at unusual thresholds, they could explain the unpredictable brightening and the chemical signatures that defy expectations. Whatever the truth, each theory seems only to underline how alien this visitor truly is. The public continues to follow the unfolding story, drawn by the notion of a countdown to discovery. News reports highlight the coincidence of dates: a close pass by Mars on October 3rd, a superior conjunction on October 21st, and perihelion on October 31st. The alignment with familiar calendar milestones lends the narrative a rhythm that feels almost staged, as though the universe itself had orchestrated a sequence of revelations. Astronomers, though wary of dramatization, acknowledge the sense of destiny in the timing. Rarely does science unfold with such sharp moments of anticipation, each tied to astronomical geometry and celestial mechanics, yet imbued with mystery. As October progresses, one question begins to dominate: will 3 Atlas survive perihelion? Many comets fragment when they swing close to the Sun, their internal structures unable to withstand the combined forces of heat and gravity. If the nucleus is fragile, it may disintegrate entirely, leaving only dust and gas behind. If it is resilient, it may endure, offering post-perihelion observations that could reveal how its chemistry changes after the closest encounter. The unpredictability of its brightening only amplifies the uncertainty. Some argue that its surges of activity suggest internal weakness. Others note that its coma, though vast, remains coherent, a sign of structural strength. Both views find support in the data, and neither can claim certainty. The fate of the interstellar visitor remains poised on a knife's edge. In the meantime, every observation carries a sense of urgency. The last nights before conjunction become precious, for soon Earth-based instruments will be blind. Astronomers calculate exposures with precision, trying to glean one more measurement before the Sun swallows the object in glare. The comet itself, indifferent to the human scramble, rushes onward at nearly 68 kilometers per second, its trajectory curved by the Sun's pull, its chemistry evolving in ways no one fully understands. To watch it is to feel the press of time, the fleeting nature of an encounter, measured not in decades or centuries but in days. By mid-October, the brightening trend shows no sign of slowing. The light curve continues to climb, diverging ever further from the models drawn months earlier. If the pace continues, some speculate the comet might even become faintly visible to the naked eye under dark skies, a prospect that excites public imagination, even as astronomers temper expectations. Still, the idea captures headlines: an interstellar object glowing green, potentially visible without aid. Even if it never reaches that threshold, the mere possibility adds to the sense of anticipation, the feeling that 3 Atlas is a messenger bearing news from beyond its message, written in light curves, spectra and anomalies that resist easy translation. And so the days of October march forward, each one carrying the comet closer to its perilous encounter with the Sun. The Mars flyby is complete data in transit, but the superior conjunction lies ahead, a curtain that will fall between humanity and the object for crucial days. The story builds like a symphony toward its climax, every instrument of observation straining to capture the notes before silence descends. In the widening coma, in the surging brightness, in the anomalous anti-tail pointing defiantly toward the Sun, the mystery of 3i Atlas only deepens. What secrets lie within its nucleus? What chemistry drives its unpredictable glow? And what fate awaits it at perihelion remain unanswered. The world can only wait, watching an interstellar enigma race through the inner solar system, bearing the weight of questions that may linger long after it is gone. As the calendar edges toward mid-October, the tension around 3i Atlas intensifies. The interstellar traveler is now entrenched in the inner regions of the solar system, its speed climbing as gravitational pull from the Sun accelerates its trajectory. From Earth, the sight of it grows more difficult each evening, for the geometry of its orbit brings it ever closer to the Sun's glare. Observers know that soon it will pass behind the solar furnace in superior conjunction hidden from direct view, and when it re-emerges the perihelion will already be imminent. This narrowing window of visibility turns every clear night into a race against time. Data is precious, images fleeting, and the questions mounting. The brightness surge that began in September continues unabated. Each new measurement confirms that the light curve has broken free from expectation. In astronomical terms, the deviations are not small, they are profound. Predictions had suggested the object might reach a modest magnitude by perihelion, requiring telescopes for observation. Instead, it has already exceeded those forecasts weeks early, and its slope points sharply upward. Astronomers debate whether this means the nucleus is releasing more material than estimated, or whether something deeper is at play, a new category of sublimation that solar system science has never documented. Some propose that exotic ices forged in the colder reaches of another star system are responsible. Such ices, if unstable in our sun's radiation, could erupt violently, fueling the erratic increases in brightness. The idea is speculative, but speculation feels almost obligatory when the data so stubbornly resists familiar categories. The coma vast already expands further. Calculations suggest that its breadth now exceeds tens of millions of kilometers, a tenuous sphere of dust and plasma that dwarfs planets. The nucleus at the center remains invisible, hidden within the haze, its true size and shape left to inference. Some scientists argue it must be several kilometers across, while others suspect it is smaller, its brilliance magnified by violent activity. Without direct imaging, certainty remains out of reach. Yet the coma itself becomes an object of study, for within its shifting brightness lie clues to the dynamics of dusty plasma on an interstellar scale. Telescopes detect striations and faint structures within the haze, as though magnetic fields are shaping the material into filaments. To those familiar with plasma physics, the patterns are strikingly reminiscent of laboratory experiments, where charged dust organizes, spontaneously forming waves and lattice-like arrangements that suggest order within chaos. The green glow continues to attract attention, growing stronger as the comet nears the sun. Diatomic carbon, the likely source, fluoresces when exposed to ultraviolet light, and its intensity grows as radiation increases. But other spectral lines complicate the picture. Hints of cyanogen, another molecule known to fluoresce in green, appear intermittently. The proportions seem to change from night to night, as though chemical reactions are in flux. This variability reinforces the idea that the coma is not a passive reflection of the nucleus, but an active environment where molecules break apart and recombine under solar energy. Some even suggest that interstellar dust grains captured in the coma may act as catalysts, enabling reactions unfamiliar to solar system chemistry. The possibility adds another layer of mystery, for it would mean the object carries not only ices and dust, but an entire archive of chemical processes seeded in another corner of the galaxy. As the superior conjunction approaches, astronomers grow restless. The 20th of October is marked on calendars as the final reliable opportunity to capture images before the object vanishes into sunlight. After that, Earth-based telescopes will be blinded until early November. In those final nights, long exposures under clear skies yield haunting images, a luminous smear in the constellation of Virgo, its greenish halo spreading across the dark, faint stars, trailing into lines as cameras track the comet's relentless motion. These photographs become treasured artifacts, the last glimpses of a body that is rewriting what humanity thought it knew about interstellar debris. They are studied obsessively, with brightness measured, coma size, calculated tail geometry analyzed. Each frame becomes a message from the edge of observability, carrying both data and poetry. Meanwhile, attention shifts toward Mars, which by now has completed its close pass. The data collected by orbiters is beginning to trickle back. Early results confirm what Earth-based observations already hinted: the object is brighter than models predict, and its coma is vast. Instruments sensitive to specific wavelengths detect unusual ratios of carbon compounds, reinforcing the conclusion that exotic chemistry is at work. Yet the resolution is insufficient to reveal the nucleus, leaving its size and structure unknown. Even so, the mere fact that spacecraft around another planet have captured data on an interstellar visitor marks a milestone. Humanity's instruments have extended their reach, and for the first time a foreign world has contributed to the study of a foreign object. The symbolism is profound. Speculation grows as the moment of invisibility nears. Will the object survive its dive around the sun? Some argue that its erratic brightening is a sign of instability, a prelude to catastrophic disintegration. Others note that despite the chaos, the coma remains intact with no obvious fragments trailing behind. In their view, the nucleus may be stronger than assumed, able to withstand the stress of perihelion. The truth lies hidden in the days to come inaccessible, while the comet slips behind the sun. This uncertainty sharpens the suspense, for when it re-emerges, it may appear as a coherent body, a fragmented cloud, or nothing at all. The outcome is unknowable, and the anticipation builds like a held breath. For the public, the narrative is irresistible. Reports describe the approaching conjunction as a vanishing act, a moment when the alien traveller disappears into the light of the sun, only to reappear transformed. Comparisons are drawn to mythical journeys through fire and shadow stories of renewal and destruction. Scientists, though cautious, acknowledge the drama inherent in the geometry. This is no ordinary comet, and its story unfolds with a rhythm that seems almost scripted. Discovery in July, early awakening in August. Anomalous, brightening in September. Mars flyby in October. Conjunction at month's end, perihelion on Halloween. A sequence of milestones that lends itself to wonder. As October 21st arrives, 3 Atlas passes behind the sun. Instruments on Earth fall silent, their view blocked. For the next 10 days the interstellar traveller is invisible, its fate concealed within solar glare. Astronomers weight their models, diverging into possibilities: fragmentation, survival, or transformation into something stranger still. They know that the answer will not come until November, when the comet emerges once more. Until then, the mystery deepens, suspended in silence, as though the universe itself is withholding the next chapter. And so the story pauses on the brink of its climax. The interstellar visitor, once faint and unnoticed, has become the focus of global attention. A body whose behaviour defies explanation, and whose chemistry speaks of distant origins. Its coma glows green, its tail points sunward, its brightness surges unpredictably. Now it vanishes into the blaze of the sun, carrying its secrets into a realm beyond human sight. The countdown to perihelion continues, but for the moment the narrative rests in shadow, awaiting the outcome of a passage that may define its legacy. The silence of late October is unsettling. For nights on end, no telescope on Earth can pierce the brilliance of the sun to reveal 3i Atlas. Observers accustomed to nightly updates must now endure absence, their instruments idle, while speculation grows unchecked. Astronomers know that the comet has not ceased its journey. It is racing through superior conjunction hidden behind the solar disk, its speed climbing to nearly 68 kilometers per second as it draws closer to perihelion. In this invisible stage, all that can be done is to calculate, to model, and to wonder. Theories multiply in the vacuum of data. Some argue that the irregular brightening before conjunction was the final sign of instability, a precursor to collapse. Others insist that the object's persistence in retaining a coherent coma means that it will survive the ordeal, emerging intact if transformed. Both sides find support in past cometary behaviour, yet both acknowledge that 3i Atlas is unlike any comet humanity has seen before. The conjunction itself is precise, occurring on the 21st of October, when the line of Earth, Sun and comet aligns perfectly. In ancient times, such alignments were seen as omens. In modern science, they are obstacles cutting off observation at the very moment when activity is most intense. Yet the alignment also carries symbolism, an interstellar traveller, passing behind the star that defines our world, vanishing as though swallowed by the source of light and energy. When it reappears, it may bear the scars of this passage, or it may not reappear at all. The waiting is filled with tension, for the answer will not come until early November, and until then all is conjecture. Even in this pause, hints of information find their way through. Spacecraft orbiting near the Sun built for the purpose of studying solar activity may inadvertently glimpse the interstellar object as it passes close to the star. Instruments aboard the Solar and Heliospheric Observatory and NASA's Solar Dynamics Observatory are capable of detecting bright comets that skim the corona. Whether they will capture 3I Atlas is uncertain, but the possibility gives astronomers hope that the silence will not be absolute. If images appear, they may reveal the comet's coma distorted by solar wind, or even fragments scattering if disintegration has begun. Such images would be crude compared to the detailed views captured by deep space telescopes, but they would be invaluable as a record of survival or demise. Meanwhile, calculations dominate the discourse. Orbital dynamics predict that the comet will reach perihelion on the 31st of October, at a distance slightly within the orbit of Mars. Though this is not a particularly close solar passage by cometary standards, the speed of the object magnifies the forces at play. The heat of the Sun at this distance is sufficient to sublimate a wide range of ices, while the gravitational gradient stresses the nucleus in ways that may crack it apart. The outcome is uncertain because the physical structure of the body is unknown. If it is a dense monolith, it may endure. If it is a porous aggregate bound weakly by cohesion rather than strength, it may fail catastrophically. The data prior to conjunction cannot decide between these possibilities. Only observation after perihelion will reveal the truth. The unpredictability of the light curve feeds into this suspense. Before conjunction, the brightness had climbed beyond expectations with sharp increases that defied smooth modelling. If this trend continues, then the comet may emerge far brighter than anyone had dared hope, perhaps even visible to the naked eye under dark skies. Such a possibility excites the imagination of the public who follow the story through news reports that speak of a cosmic countdown. The symbolism of the date perihelion falling on Halloween adds to the allure, casting the event in the language of transformation of a passage through shadow into light. Scientists are wary of exaggeration, yet even they cannot resist the sense of narrative in the unfolding sequence of events. Speculation about the chemistry of the nucleus fills the void left by observation. The presence of diatomic carbon is well established, but the changing intensity of its emission lines suggests processes beyond simple sublimation. Some propose that cosmic rays during the object's billion-year journey through interstellar space altered its chemistry, embedding energy into ices that is only now being released. Others suggest that dust grains from the interstellar medium became embedded within the body, carrying compounds unknown to the solar system. As these grains are liberated into the coma, they may catalyze reactions that produce the unusual glow. The coma then becomes not just a veil of dust, but a crucible where alien chemistry plays out under the light of the sun. The anti-tail remains a subject of fascination even in absence. Astronomers debate whether its persistence is a true anomaly or merely an effect of perspective. Yet the data collected before conjunction shows that material was consistently oriented sunward, not anti-sunward, for weeks at a time. Such behavior defies ordinary dynamics, where radiation pressure and solar wind inevitably drive dust away from the sun. Plasma models offer partial explanations invoking the influence of interplanetary magnetic fields, yet the scale of the effect remains troubling. It is as though 3 Atlas carries its own invisible scaffolding, a memory of electric and magnetic forces from interstellar space that continues to shape its response even within the solar system. If true, it would mean that this object does not merely adapt to its environment, but brings with it the imprint of its long voyage, an echo of fields and forces that exist far beyond our reach. For the scientists who study it, the pause of conjunction is both frustration and opportunity. The lack of data is a gap, but the time allows reflection on what has already been learned. In just a few months, 3I Atlas has shown itself to be unlike any comet or asteroid. It awakens early, brightens, erratically glows green with unexpected chemistry, and points its tail toward the sun. It challenges assumptions about what interstellar objects should be, just as ʻOumuamua and Borisov did before it. With only 3 such objects ever observed, the conclusion becomes clear: there is no standard model for interstellar visitors. Each is unique, bearing the history of its origin system and the scars of its interstellar journey. Together they hint at a diversity far greater than we imagined, a cosmos filled with bodies that defy easy classification. As October draws to a close, the narrative builds toward its climax. The comet is invisible, now hidden behind the brilliance of the sun, but in imagination it is alive with change. Perhaps jets erupt from its surface, carving the coma into new shapes. Perhaps fractures split the nucleus, scattering fragments along its path. Perhaps it endures, glowing ever brighter as it swings around perihelion. The truth lies hidden in solar glare, waiting to be revealed. The countdown continues, and with it grows the sense that whatever emerges in November will not just be data, but revelation. For in the silence of conjunction, the interstellar traveller carries its secrets through fire and shadow, preparing to show the solar system what lies beyond. The final days of October unfold like the calm before a storm. Across the world, observatories stand in anticipation, their instruments pointed not at the hidden interstellar visitor, but at the blank sunlit sky where it lingers out of sight. The object, 3I Atlas, has entered its most perilous phase. On the 31st of October, perihelion arrives, the moment of closest passage to the Sun, when its speed peaks near 68 kilometers per second. Though the geometry keeps it well beyond the corona, the radiation and gravitational stresses at that distance are sufficient to test the structural strength of any icy body. For ordinary comets, such passages often end in disintegration. For an interstellar object already prone to anomalies, the outcome is unknowable. During conjunction, silence reigns. The comet has disappeared behind the sun, and no telescope on Earth can pierce the glare. Yet astronomers are not entirely blind. Instruments designed to monitor solar activity perched in space between Earth and the Sun record wide-field images of the corona. Occasionally bright comets skim into view, captured as streaks of light crossing the halo of plasma. As perihelion approaches, scientists scrutinize these data streams, hoping to glimpse the green-tinged visitor. A few faint traces appear indistinct against the solar background, but suggestive of survival. The signals are ambiguous, yet they offer hope that 3I Atlas endures. Speculation builds as Halloween approaches. If the object disintegrates, its dust may scatter into a fan-shaped cloud dispersed by solar wind. If it survives its coma, may flare into brilliance fueled by intense radiation at perihelion. Some suggest the possibility of fragmentation, multiple bodies emerging from conjunction, instead of one, each glowing faintly as they follow similar trajectories. Astronomers remind themselves that prediction is treacherous, for the object has already broken every expectation. It awakened early, brightened erratically, and pointed its tail toward the sun. Why should perihelion behave in ways any less strange? The chemistry of the comet takes centre stage in theoretical debates. The green glow attributed to diatomic carbon may intensify under the concentrated ultraviolet light of perihelion. If so, the coma could blaze with a brilliance unseen before. Others argue that heating may liberate compounds buried deep within the nucleus, revealing molecules untouched since their formation in a distant star system. These could include exotic ices rare in our solar system that transform rapidly under solar energy. Their sublimation might account for the unpredictable jumps in brightness recorded in September and October. The idea that alien chemistry is about to be revealed excites those who imagine what spectrographs might record once the comet emerges again into view. At the same time, the structural fate of the nucleus remains an enigma. If it is porous and fragile, perihelion may spell its end. Yet the coherence of its coma before conjunction suggested resilience. Unlike some comets that shed fragments visibly, 3I Atlas remained whole, even as it brightened unpredictably. This persistence hints at a stronger body, perhaps a dense mixture of rock and ice capable of enduring stress. But without direct imaging, certainty is impossible. The object is shrouded in haze, its core invisible. It could be monolithic or a loose rubble pile. It could survive intact or collapse into dust. The truth waits behind the veil of the sun. For those who follow the story, the timing feels uncanny. Perihelion on the 31st of October. Halloween seems like more than coincidence. Media reports emphasize the symbolism, portraying the event as a cosmic drama in which the alien traveler passes through fire on a night devoted to transformation and the thinning of veils. Scientists remain cautious, but cannot deny the poetic rhythm of the unfolding sequence. Discovery in July, awakening in August, anomaly in September, Mars flyby in early October, invisibility in late October, perihelion on Halloween, each stage falling into place like chapters in a story written across the heavens. Behind the drama, data from Mars orbiters begins to arrive. Though limited, it provides confirmation of the comet's vast coma and unusual chemistry. Spectrometers detect stronger than expected emissions in carbon compounds, reinforcing the idea that interstellar chemistry is shaping its behavior. The green glow already evident from Earth is confirmed from another planet. To imagine an interstellar object studied simultaneously from Earth and Mars is to recognize the expansion of human presence in science. For the first time, two worlds coordinate in observing a body from beyond the solar system. The significance resonates deeply, hinting at a future where interplanetary cooperation becomes the norm in unraveling cosmic mysteries. On Earth, the absence of nightly images deepens the sense of suspense. Enthusiasts who once stacked frames and compared light curves now wait impatiently, staring at blank sky maps. The silence is a void that invites imagination. Some picture the comet disintegrating in a sudden flash, scattering into dust unseen. Others envision it blazing brighter than ever, its coma doubling in size as perihelion fuels its fury. Still others dream of fragments, multiple glowing points emerging in November, each a shard of the original, each carrying part of its story. In the absence of data, every possibility seems alive. Plasma physicists reflect on what perihelion might mean for the anti-tail. If the orientation of its emissions has already defied convention, then close solar passage may amplify the effect. The sun's wind, more intense at this distance, might sculpt the plasma into arcs or sheets bending in directions unseen in ordinary comets. If so, the images to come may reveal patterns as strange as any laboratory experiment, vast structures shaped by electromagnetic forces that span millions of kilometers. Such phenomena could hold clues to plasma behavior in environments far beyond Earth, offering insights not only into 3I Atlas, but into the fundamental dynamics of charged matter in space. The countdown to perihelion feels less like observation and more like a vigil. Around the world, astronomers wait for the moment when the comet will swing closest to the Sun. They know the data will not be immediate. It will take days or weeks for images to confirm its fate, but the moment itself is marked on calendars and clocks a point in time when an interstellar traveller brushes the edge of destruction. The thought inspires awe. For billions of years it wandered unseen between stars carrying chemistry shaped by distant suns. Now, for the span of a single Earth year, it crosses our system, dives near our star, and invites us to witness. On the 31st of October, perihelion arrives. Somewhere behind the brilliance of the Sun, 3 Atlas rushes past the point of closest approach, its velocity peaking its nucleus, enduring or shattering its coma, blazing or dispersing. Humanity cannot see it not yet, but imaginations are fixed on the moment. Will it emerge brighter, stranger transformed? Will it scatter into dust, leaving only a faint trace? Or will it vanish entirely, its secrets lost to light? For now, no answer is possible. The traveller remains hidden in solar glare, carrying its mysteries through the furnace of the Sun, leaving Earth to wait in silence for its return to view. When November dawns, the astronomical world waits in suspense. Days have passed since 3I Atlas skimmed its closest approach to the Sun, and no one knows what form it will take when it emerges from the blinding solar glare. Observers peer into the morning sky, stacking images, comparing faint smudges of light against fields of stars searching for any sign of survival. Slowly reports begin to trickle in. The object has not vanished. It has endured its fiery passage and now shows itself again, dim but intact, still trailing a vast halo of gas and dust. Relief spreads through the community, though it is tempered by curiosity, for the returning comet looks altered, as though perihelion has reshaped it. The first measurements after conjunction reveal that its brightness has surged beyond even the wild predictions made in October. For a brief period, 3I Atlas glows far more strongly than models allow, suggesting that perihelion unleashed hidden reserves of volatile material. Its coma, once enormous, appears larger, still expanded by intense heating. Spectral analysis detects fresh surges of diatomic carbon, confirming that chemical transformations have taken place. The green glow, once subtle, now shines more distinctly, filling long exposure images with a spectral aura. Yet alongside this brightness comes irregularity. Some nights show rapid dimming, followed by renewed bursts. The object behaves less like a steady comet, and more like a living system pulsing with energy in unpredictable rhythms. Attention focuses on whether the nucleus remains whole. Some astronomers report faint evidence of multiple condensations within the coma, as though fragments may have broken away. Others caution that such impressions may be artifacts of image processing. The debate recalls the fate of other comets that fractured near the Sun, scattering into debris fields. If 3I Atlas has split, then each fragment may follow its own fading path, complicating observations. Yet no clear train of fragments has yet been confirmed. For now, the safest conclusion is that the body has survived, though perhaps not without scars. The possibility of fragmentation lingers, another unanswered question in a narrative filled with them. The geometry of its emissions adds to the strangeness. Post-perihelion images reveal that the anti-tail persists, still pointing sunward when theory insists it should not. In fact, the orientation seems even more pronounced than before, as though the close solar passage reinforced the anomaly. Plasma physicists study the new data, eagerly comparing it with models of charged dust interacting with solar wind. Some suggest that perihelion may have charged the coma, more strongly aligning dust grains with interplanetary magnetic fields. Others suspect that structural memory patterns imprinted during its interstellar voyage continues to dictate how its plasma organizes. Either way, the persistence of the anti-tail underscores that this is no ordinary comet. Public fascination intensifies with the news of survival. Newspapers and broadcasts describe it as a ghostly wanderer reborn from fire. The coincidence of perihelion on Halloween amplifies the imagery, making the comet seem like a cosmic symbol of death and renewal. Amateur astronomers point their telescopes skyward, hoping to glimpse the green glow themselves. Though it remains too faint for most naked-eye observers, long exposures with modest instruments capture it the faint smear of light against constellations in the pre-dawn sky. Each image shared online fuels excitement, a communal sense of witnessing something that will never come again. Scientists are more cautious, but their excitement is real. They know that every detail gathered now contributes to understanding not only 3I Atlas, but the diversity of interstellar objects as a whole. Already comparisons are drawn to ʻOumuamua and Borisov, where the first showed no coma and accelerated mysteriously, and the second resembled a comet, but with unusual grain structure. The third combines cometary activity with anomalies that defy categorization. Each interstellar object adds another layer of complexity, suggesting that the galaxy is filled with bodies shaped by environments utterly unlike our own. 3I Atlas, with its green glow, massive coma and sunward emissions, is the strangest yet. The Mars flyby data, now more fully processed, provides valuable context. Orbiters captured the comet's coma in ultraviolet and infrared, confirming unusual ratios of carbon compounds. Some instruments detected fluctuations in brightness that match the pulses seen from Earth, suggesting that the irregular surges are real, not artifacts. Together, Earth and Mars observations offer a stereoscopic view, hinting at structures within the coma that shift and reorganize on timescales of hours. Plasma dynamics once confined to laboratory chambers may be playing out on planetary scales, revealing a natural experiment too vast to reproduce on Earth. Speculation begins to reach further. If interstellar comets like 3I Atlas carry exotic chemistry, then they may also carry clues to the origins of life. Some scientists propose that such bodies could seed planetary systems with complex molecules delivered during close encounters. If so, the arrival of 3I Atlas in our solar system is not merely an astronomical event, but a glimpse into a galactic process, one in which chemistry and biology intertwine across light years. The green glow of diatomic carbon becomes more than a curiosity. It becomes a symbol of the cosmic exchange that may shape life itself. Others resist such speculation, preferring to keep interpretations within the bounds of physics and chemistry. Yet the mystery of the comet's behavior makes it difficult to draw strict boundaries. As November advances, the comet begins to fade slowly, though irregular bursts of brightness continue. Its trajectory carries it outward away from the Sun, retracing its arc back toward interstellar space. It will not return. Its path is hyperbolic, carrying it beyond the pull of the Sun out into the galaxy once more. Observers are keenly aware that this is their last chance to study it, for once it recedes, it will vanish forever. This awareness lends weight to every exposure, every spectrum, every data point. They are the only record humanity will ever have of this alien body, yet questions persist. Why did its light curve diverge so radically from predictions? What caused the anti-tail to endure? How did its chemistry transform so suddenly at 2 astronomical units? Was its nucleus fractured, or did it remain intact? Each question remains open even as data accumulates. The more scientists learn, the more they realize how little is understood. 3I Atlas is not just another comet. It is a messenger from beyond carrying secrets that resist interpretation. Its survival through perihelion ensures that those questions will linger unanswered as it fades into the dark. For now, the comet remains a presence in the sky, faint but detectable, still glowing green, still racing outward. The spectacle of its perihelion survival ensures its place in history alongside ʻOumuamua and Borisov as one of the rare interstellar objects to grace our system. Each visitor has challenged assumptions, expanded imagination, and reminded humanity of its place in a galaxy filled with wonders. As 3 Atlas departs, it leaves behind not closure but a widening of mystery, a reminder that the universe is richer and stranger than expectation allows. The days following perihelion bring a mixture of astonishment and unease. 3 Atlas has survived its closest passage to the Sun, but its condition appears unstable. Its coma, already vast before conjunction, now seems to shift and breathe like a living organism, swelling outward in one observation and contracting in another. Some astronomers interpret these fluctuations as evidence of ongoing outbursts from the nucleus, sudden releases of volatile material triggered by stresses accumulated during perihelion. Others suspect that the coma itself has become a dynamic plasma environment where charged particles interact with magnetic fields in ways that alter brightness unpredictably. In either case, the object's post-perihelion behavior is unlike anything known from solar system comets. The light curve continues to deviate sharply from projections. Instead of declining steadily after perihelion, as most comets do, the brightness of 3I Atlas wavers unpredictably. On some nights it dims as though fading only to brighten again days later. Amateur astronomers track these changes with meticulous care, adding new points to a graph that has long since abandoned the smooth arc of prediction. Professionals too devote their instruments to the task, though time on large telescopes is scarce. Every new data set confirms that the object refuses to follow rules. It seems to operate on its own timetable, driven by forces yet unrecognized. Spectroscopy becomes the key tool in unraveling the mystery. Post-perihelion spectra show not only diatomic carbon, but a surprising variety of other molecules. Cyanogen faint before now appears more strongly. Oxygen-bearing compounds too emerge, though in ratios that puzzle chemists. The balance of elements suggests reactions occurring within the coma itself, not merely the release of material from the nucleus. This supports the growing theory that 3 Atlas is a chemical laboratory in motion, where solar radiation drives transformations that cannot be reproduced in terrestrial labs. Some researchers even propose that dust grains carried by the object contain catalysts that accelerate these reactions, remnants of the interstellar medium imprinted into the comet during its long voyage. If true, the green glow that fascinates the public is only a hint of a far richer chemistry unfolding invisibly within the haze. Images reveal further anomalies. Instead of forming the graceful dust tail expected after perihelion, the object continues to display its strange sunward orientation. The anti-tail, rather than disappearing, grows more distinct. In long exposures, filaments of light seem to stretch toward the sun, defying the push of solar wind. Plasma physicists analyze these patterns with interest, noting similarities to structures seen in dusty plasma experiments. Filament arcs and vortices appear spontaneously in such systems shaped by electromagnetic fields rather than mechanical forces. If the coma of 3I Atlas is indeed such a plasma, then its strange geometry is not a violation of physics, but an expression of hidden order. Still, the persistence of the anti-tail leaves many uneasy. It suggests that the comet carries with it conditions imprinted not by the sun but by environments it encountered in interstellar space. The possibility of fragmentation continues to dominate discussion. Some observers claim to detect faint secondary points within the coma potential fragments that split from the nucleus during perihelion. Yet the evidence remains ambiguous. Atmospheric distortion image processing and background stars can all mimic such features. Until confirmed by multiple independent observations, the question of fragmentation remains open. But if pieces have indeed broken away, then the future brightness of 3E Atlas may depend on whether those fragments remain large enough to sublimate vigorously. The thought that multiple shards of an interstellar body may now be travelling outward together is both thrilling and haunting. Each fragment would carry part of the original's history destined to fade into interstellar darkness once more. The public fascination continues to grow, fueled by dramatic headlines and haunting images. Reports describe the comet as a survivor reborn from its fiery passage. The coincidence of perihelion on Halloween lingers in the narrative, adding to its aura of mystery. Amateur astronomers around the world attempt to photograph it, stacking images to capture the faint green glow against the night sky. For many, the act of seeking it is as important as the result. To stand beneath the stars and know that a fragment from another star system is visible above is to feel connected to the vastness of the galaxy. The images shared online, small fuzzy patches of light, become symbols of wonder, reminders that the universe still surprises. Scientists, while cautious about overstatement, share in the awe. They know how rare such opportunities are. Only 3 interstellar objects have ever been confirmed: ʻOumuamua, Borisov, and now 3I Atlas. Each has been radically different, defying the notion of a standard model for such visitors. ʻOumuamua showed no coma, but accelerated strangely as though pushed by forces unseen. Borisov resembled a comet, but revealed unusual dust properties. 3I Atlas combines cometary features with anomalies that challenge fundamental understanding, unpredictable brightening alien chemistry and sunward emissions. The diversity suggests that the galaxy is filled with bodies far more varied than those confined to our solar system. Every interstellar visitor adds a new chapter, expanding the boundaries of possibility. Theories proliferate. Some suggest that 3I Atlas may have originated in the debris of a shattered planet, ejected into interstellar space by gravitational chaos. Others imagine it as a remnant from the early days of a star system, a frozen archive of conditions that no longer exist. More speculative voices wonder whether its plasma behavior indicates something beyond mere matter, a form of self-organization that blurs the line between physics and biology. Could interstellar objects like this carry not just chemistry, but patterns of order, seeds of complexity scattered across the galaxy? Such thoughts remain far from proof, but they highlight how 3I Atlas stretches imagination as much as science. As November progresses, the comet begins its long retreat from the Sun. Its trajectory carries it outward away from the inner solar system, destined never to return. Yet for now it remains within reach of telescopes, still glowing faintly, still offering data. Each night of observation becomes a race against fading brightness, a chance to capture one more spectrum, one more image before it slips beyond detection. Scientists know that within weeks the opportunity will be gone forever. This sense of urgency is palpable. To study 3I Atlas is to study a messenger from beyond, and once it leaves, its secrets will remain locked within fragments, travelling through interstellar space for untold millennia. The comet's story has already transformed understanding. It has shown that interstellar visitors need not conform to familiar categories, that they may awaken earlier, brighten faster, and behave more strangely than models predict. It has suggested that alien chemistry can survive for eons and reveal itself under the touch of a new star. It has demonstrated that plasma dynamics may sculpt comet in ways far beyond what solar system comets display, and it has reminded humanity that the galaxy is alive with wanderers each carrying a history written in dust and ice. Yet even as knowledge grows, questions multiply. Why did the light curve surge so steeply? What compounds fuel the green glow? Has the nucleus fractured, or does it remain intact? Why does the antitail persist so defiantly sunward? No answers are final, and perhaps none ever will be. The comet will fade, data will be archived, and debates will continue. Its secrets may never be fully known. But its passage has already achieved something greater. It has reignited wonder, reminding humanity that the universe is not predictable clockwork, but a realm of mystery where each new discovery opens doors to the unknown. The return of 3i Atlas to view after perihelion transforms the scientific conversation into a debate about survival versus transformation. Observers had expected the interstellar traveller to fade steadily as it moved outward, its volatile materials depleted by the sun's heat. Yet the object refuses to conform. Instead of diminishing predictably, it displays bursts of renewed activity, sudden flares of brightness that defy the declining trend. On certain nights in early November, telescopes capture spikes in magnitude, as though the nucleus continues to vent with unexpected vigour. These irregular pulses suggest that perihelion did not exhaust the body, but rather exposed deeper reservoirs of volatile material, now sublimating as fresh surfaces meet the solar wind. The nature of the nucleus remains hidden within the coma, but indirect clues emerge. Brightness fluctuations, coma asymmetries, and hints of multiple condensations within the haze all point toward internal complexity. Some astronomers argue that the nucleus may have fractured into several large pieces, each contributing to the observed activity. Others counter that the evidence is too ambiguous, that processing artifacts and shifting plasma structures could mimic fragmentation. The debate remains unresolved, yet the possibility of a nucleus divided by solar stress adds a dramatic layer to the narrative. If true, then Earth is witnessing not just the passage of an interstellar object, but its disassembly, a body carried for eons across the galaxy, now unravelling under the gaze of our Sun. The chemical signatures recorded after perihelion are equally provocative. Spectral data reveal shifts in molecular composition with diatomic carbon still dominant, but accompanied by growing traces of oxygen and nitrogen-bearing species. These compounds, rare in solar system comets, hint at processes unfamiliar to terrestrial chemistry. Some researchers suggest that exotic ices perhaps formed in molecular clouds before the object's ejection are now sublimating. Others propose that reactions in the coma driven by intense radiation are manufacturing these compounds anew. Either explanation underscores the alien nature of 3i Atlas. Its chemistry is not simply a mirror of our comets, but a record of environments far beyond the solar system, preserved across unimaginable spans of time. The persistence of the antitail continues to confound. Post-perihelion images confirm that material still points sunward, defying the simple expectation that dust should stream away from the sun. Plasma physicists attempt to model the phenomenon, invoking magnetic reconnection and field-aligned currents as possible explanations. Yet the scale and coherence of the structure remain difficult to account for. Some argue that the comet's rapid velocity through the heliosphere may be shaping bow-shocks and charged particle flows in novel ways. Others speculate that the object's long interstellar voyage imprinted it with electric charge distributions that continue to influence its behaviour. Whatever the cause, the antitail stands as one of the most persistent anomalies of the encounter, a symbol of the limits of human understanding. the public enthralled by the comet's survival continues to follow its progress. Media outlets frame it as a ghostly survivor reborn from fire carrying alien chemistry into our skies. Amateur astronomers contribute images nightly, capturing the green halo even as it dims. Each photograph shared online reinforces a sense of collective witnessing. People who had never before considered the mechanics of light curves or molecular fluorescence now discuss diatomic carbon and dusty plasma as though they were common vocabulary. The comet has bridged the gap between professional science and public imagination, serving as a reminder that wonder is not confined to observatories. Within the scientific community, comparisons with earlier interstellar visitors grow sharper. ʻOumuamua had been enigmatic in its silence, displaying no coma, but accelerating as if pushed by invisible forces. Borisov, in contrast, resembled a comet more closely, though its dust properties marked it as unusual. Now, 3I Atlas arrives as a synthesis of both strangeness and familiarity. It bears a coma like Borisov, yet its chemistry and dynamics diverge from any solar system precedent. In doing so, it underscores the variety of interstellar objects. There is no standard template, no typical interstellar visitor. Each is unique, shaped by the peculiarities of its birth system and its journey through galactic space. The lesson is humbling. The galaxy is a mosaic of histories, and each fragment we glimpse reveals only a fraction of its richness. Theories about origin proliferate. Some suggest that 3I Atlas may have formed in the outer reaches of a distant planetary system later ejected by gravitational encounters with giant planets. Others propose that it could be a shard of a shattered body, the debris of a planetary collision billions of years ago. More speculative voices imagine that it could be a relic of star formation itself, a frozen remnant from a molecular cloud carrying chemistry unaltered since before planets coalesced. Each theory speaks to the object's uniqueness, but none can be proven. The distances are too vast, the histories too long. The comet offers only fragments of evidence, and interpretation must remain tentative. In the background of these debates lies a deeper question. What role do such interstellar objects play in galactic ecology? If 3I Atlas carries exotic ices and complex molecules, then it may represent one of countless couriers moving between systems. Over billions of years, such wanderers could transfer material from one star's domain to another, scattering the ingredients of planets and life across the galaxy. The idea that our solar system may now be sampling the chemistry of another system excites those who ponder the origins of life. Could comets like 3I Atlas have delivered building blocks to early Earth? If so, then life on our planet may be linked not just to the Sun, but to countless stars scattered across the Milky Way. The thought stretches imagination, but it is grounded in the evidence of alien chemistry glowing green in the sky. As November advances into its second half, the comet begins to fade more steadily. Its bursts of activity grow less dramatic, and its light curve at last starts to decline. Yet even as it dims, telescopes continue to track it, determined to capture every possible observation before it recedes beyond reach. The data sets expand, forming archives that will be studied for decades. Astronomers know that the mysteries of 3I Atlas will not be solved quickly. They will linger, inspiring new models, new experiments, and new missions designed to catch future interstellar visitors. The comet itself will soon be gone, but its legacy will remain. For now, it shines faintly in the night sky, still a messenger from beyond, still a puzzle unsolved. Each photon it reflects carries the story of a journey begun long before Earth knew life, a story shaped by stars and space and time beyond human comprehension. To observe it is to glimpse the vastness of the galaxy, condensed into a single fragment, to witness the unknown brushing past the sun before vanishing again into the dark. By late November 32nd, Atlas has moved beyond its perilous brush with the sun, yet its story is far from finished. As it retreats outward, observers continue to record its fading light, noting every subtle change in brightness, every irregular pulse of activity. Though the comet is growing dimmer, its behavior remains unpredictable. On some nights the brightness drops sharply, as though the reservoir of volatile material is finally depleting. On others, sudden flares return brief bursts of light that suggest pockets of exotic ices are still venting gas and dust. The inconsistency keeps astronomers alert, for even in retreat the interstellar visitor defies simple prediction. The comet's coma, though shrinking compared to its pre-perihelion maximum, still stretches across millions of kilometers. Images reveal delicate filaments within it, strands of dust and plasma that weave and twist in patterns too intricate to be random. Some compare the structures to the filigree seen in auroras or plasma discharges, phenomena governed not by gravity alone but by the subtle choreography of electromagnetic forces. In laboratory experiments, dusty plasmas form lattices and vortices that mimic the structures of living tissue. To see such order implied on an astronomical scale is unsettling, for it hints at processes that blur the distinction between physics and something more. Spectroscopic studies continue to reveal complexity. Post-perihelion measurements show not only carbon-based molecules, but also faint signatures of compounds rarely seen in solar system comets. Some of these may be breakdown products of interstellar ices irradiated over millions of years. Others may be molecules forged anew in the high-energy environment of the coma itself. The proportions shift unpredictably, reinforcing the idea that the coma is an active laboratory, where sunlight drives reactions at a scale far beyond terrestrial chemistry. For scientists, each spectrum is a glimpse into the chemistry of another world, preserved across cosmic distances and revealed only in the brief span of its passage near the sun. The question of fragmentation continues to haunt observers. Though no definitive evidence of multiple nuclei has emerged, hints persist. Certain images show condensations within the coma, as though fragments lurk within the haze. These features are difficult to confirm for the faintness of the comet, and the interference of background stars make interpretation uncertain. Yet the possibility that the nucleus has fractured remains alive, and some argue that the irregular bursts of brightness are best explained by multiple active fragments sublimating at different rates. If so, then 3i Atlas is already a collection of bodies rather than a single one, a scattered remnant of what once was whole. The persistence of the anti-tail remains the most striking anomaly. Even as the comet recedes, material continues to orient sunward a geometry that should be impossible under ordinary dynamics. Theories proliferate. Some suggest that the comet's velocity, still immense, may generate unusual shock structures as it plows through the solar wind. Others argue that residual electric charges carried from interstellar space may be shaping the dust guiding it against expectation. Whatever the explanation, the anti-tail has become the defining feature of 3i Atlas, a signpost of its alien nature. To many it represents the refusal of the object to conform to human categories, a reminder that the universe is not obliged to fit the models of terrestrial science. As the comet recedes, comparisons with its predecessors sharpen. ʻOumuamua was silent and enigmatic, a shard without a coma that accelerated mysteriously. Borisov was more familiar, a cometary body that nonetheless revealed dust unlike any known in our system. Now 3i Atlas stands apart, displaying both the activity of a comet and the defiance of anomalies, a green glow, unpredictable brightening, and a tail that points toward rather than away from the sun. Together, the three visitors form a sequence of mysteries, each more complex than the last. The pattern suggests that interstellar space is filled with diversity far greater than imagined. No two objects are alike, and each one expands the horizon of possibility. The question of origin remains unsolved. Some models suggest that 3I Atlas was ejected from the outer reaches of a distant planetary system, cast adrift by gravitational interactions with giant planets. Others imagine it as a remnant of a planetary collision, a fragment launched into interstellar space by cataclysm. More speculative ideas place its birth in the heart of a molecular cloud, where ices condense in environments older than stars themselves. Each possibility carries implications not only for the object itself, but for the galaxy at large. If such bodies are common, then fragments from countless systems traverse interstellar space, crossing paths with stars and planets scattering the materials of life. The public remains captivated. Stories of the comet's survival and its strange green glow continue to circulate, often framed in the language of rebirth and endurance. Amateur astronomers post their last images as the comet fades, aware that soon it will be beyond their reach. For many, the experience has been transformative. To glimpse, however faintly, a body from another star system is to feel the scale of the galaxy in a personal way. The comet has become more than a scientific object. It is a symbol of connection to the wider cosmos, a messenger from beyond that briefly shared its secrets before departing again into the dark. Within the scientific community, 3I Atlas sparks discussions of the future. If interstellar objects arrive more often than once thought, then new missions may be designed to intercept them. Concepts are already proposed spacecraft held in readiness to launch on short notice, able to rendezvous with a newly discovered visitor before it vanishes. The anomalies of 3I Atlas strengthen the case. If each interstellar object is unique, then direct exploration becomes essential. Remote observation reveals only fragments of the story. To touch, sample, or even orbit such a body would open windows into the chemistry and history of other stars. The dream of such missions grows stronger in the wake of this encounter. By December 3rd, Atlas is well on its way outward, its brightness declining with each passing night. Yet its story lingers, recorded in terabytes of data etched into memory as one of the strangest celestial events of the era. It has shown that the galaxy is not silent but active, sending fragments across the void that carry with them the signatures of alien chemistry and physics. It has reminded humanity that mystery is not a rarity, but a constant waiting in the sky for those who look, and it has left behind questions that will not be answered quickly, questions that may remain open until the next visitor arrives. The comet recedes into darkness, its green glow fading, its coma dispersing into space. Soon it will be invisible to all but the largest telescopes, and eventually even those will lose it. Yet the encounter will not be forgotten. For a brief span of months, a body from another star passed through our system, awakened by our sun, transformed before our eyes, and then vanished. Its presence has deepened wonder, expanded knowledge, and left behind a trail of unanswered questions. The secrets of 3I Atlas remain only partially revealed, and perhaps that is fitting, for mystery is not meant to be solved entirely. It is meant to endure, to remind us that the universe is greater than our understanding, and that beyond the light of our sun, countless other stories are waiting to arrive. As December unfolds, the glow of 3I Atlas fades steadily, yet its presence lingers in the minds of those who observed it. Each night brings dimmer returns, but astronomers remain vigilant, determined to extract every last detail before the comet recedes beyond the limits of detection. Long exposures reveal a shrinking coma, its once vast halo contracting as sublimation slows in the weakening sunlight. Still, even diminished, it remains immense, far larger than the planet that gave it attention during its flyby in early October. Its retreat is not silent, for irregular bursts of activity continue occasional surges in brightness that defy the expectation of steady decline. These pulses seem almost like echoes, the dying breaths of volatile reservoirs hidden deep within the nucleus exposed by perihelion and now burning away in unpredictable rhythms. The debate over the nucleus's condition continues to occupy scientific discussion. Some argue that the fluctuations in brightness are consistent with fragmentation, that several large pieces now orbit in loose formation, each contributing gas and dust to the shared coma. Others caution that evidence remains inconclusive, and that plasma instabilities within the coma itself could mimic the appearance of multiple sources. Without clear resolution, the mystery persists. If the nucleus has fractured, then 3I Atlas is both whole and broken, a collection of alien shards travelling outward together, destined to separate more completely as time passes. If it remains intact, then its erratic activity is testimony to chemistry, unlike any known from solar system comets. Either interpretation leaves questions unanswered, and both are studied with equal vigour. The green glow continues, though fainter now as distance and reduced radiation diminish its intensity. Spectrographs still detect the hallmark lines of diatomic carbon, but their strength wanes with time. Yet other signatures remain faint but persistent, including compounds rare in solar system comets. Some of these may be remnants of ices altered by cosmic rays during the object's long interstellar voyage, molecular fossils of environments untouched by human science. Others may be transient products of reactions unique to the coma-fleeting structures that exist only under the influence of solar ultraviolet radiation. To catalogue them is to glimpse chemistry shaped not by our sun, but by alien histories. Each spectrum adds to the growing archive a record of molecular diversity carried from beyond. The anti-tail remains visible even as brightness fades. Against all expectation, material continues to orient sunward, stubbornly resisting the outward push of solar radiation. The persistence of this feature has become the signature anomaly of 3 Atlas, the element of its behaviour that refuses all conventional explanation. Plasma models offer possibilities, but none fit perfectly. Some researchers propose that the interstellar traveller carries a residual electric charge from its journey, an imprint of countless interactions with interstellar fields. This charge preserved across time might guide dust in ways alien to our experience. Others consider that its velocity through the heliosphere generates unique bow shocks that reshape material into sunward filaments. Whatever the cause, the anti-tail endures as a reminder that some mysteries are not solved in months, but may linger for decades. The comet's retreat sharpens awareness of its rarity. Only 3 interstellar visitors have ever been confirmed, each unlike the last. ʻOumuamua, enigmatic and silent, passed quickly without a coma. Borisov, comet-like but unusual in its dust, offered only a fleeting glimpse. Now 3 Atlas combines the cometry with the inexplicable, a glowing body, with alien chemistry and sunward structures. Each has expanded the range of possibility, and together they suggest that the galaxy holds countless variations, each shaped by its unique birthplace. Humanity has glimpsed only 3, yet even these few reveal a universe richer and stranger than imagined. For the public, the fading of the comet feels bittersweet. Enthusiasm that swelled during its perihelion survival now shifts toward reflection. Amateur astronomers post their last images, long exposures that capture only faint traces of green light. They speak of the privilege of having seen, however dimly, a visitor from beyond. For many, the experience has awakened an awareness of scale. that across the void of interstellar space, fragments from distant stars can arrive unannounced, touch our skies, and depart again forever. The comet becomes a story of impermanence, a reminder that beauty and mystery are often fleeting. Scientists, however, focus on legacy. The data collected during these months will be analysed for years. Already papers are being drafted comparing 3i Atlas with solar system comets, noting its divergences and its anomalies. Plasma physicists plan simulations of dusty plasmas under interstellar conditions, seeking to replicate the filaments seen in the coma. Chemists examine the unusual molecular ratios, considering how they might form under alien conditions. Dynamicists refine orbital models, exploring how such a body might be ejected from its parent system. Every discipline finds something in the comet's behavior that challenges existing models, and every discipline seeks to adapt. Speculation expands into broader questions. If interstellar objects like 3i Atlas carry exotic chemistry, could they play a role in seeding planetary systems with the ingredients of life? Over billions of years, wanderers may cross paths with young stars delivering molecules forged in alien environments. If so, then life on Earth may not be purely local, but part of a galactic exchange. The comet becomes more than an object of study. It becomes a symbol of connection, a courier of material across light years. Its green glow is reimagined not only as fluorescence, but as a signal of the galaxy's interwoven chemistry. The retreat of 3i Atlas also sparks discussions of preparation. With 3 interstellar objects discovered in less than a decade, astronomers reconsider how common such visitors may be. Perhaps they arrive more often than once believed overlooked until survey telescopes became sensitive enough to find them. If so, then future encounters may not be rare at all, but frequent opportunities. Missions are already being imagined, spacecraft designed to launch quickly, intercepting the next interstellar traveller before it fades. The case of 3i Atlas strengthens the argument for its anomalies, prove that remote observation alone leaves too much unanswered. A rendezvous mission could sample dust directly, analyse chemistry on the spot, and resolve mysteries that telescopes cannot. The comet thus becomes both a wonder of the present and a motivator for the future. As December advances, the comet dims, further slipping beyond the reach of smaller telescopes. Only the most powerful instruments continue to detect it, tracing its outbound arc. Its speed remains immense, carrying it steadily toward interstellar space. Within months it will be gone, indistinguishable from the faint background of the galaxy. Yet its story remains alive not only in data but in imagination. For the astronomers who studied it, the months of observation have been a whirlwind of discovery and surprise. For the public who followed it, the comet has been a reminder of mystery, a symbol of the unknown. For all it has been a messenger, a fragment of another star system that passed briefly through our own. The story of 3i Atlas is not one of resolution, but of deepening wonder. It awakened earlier than expected, brightened erratically, glowed green with alien chemistry, and pointed its tail toward the sun. It survived perihelion, against prediction persisted in its anomalies, and now recedes into the dark. Its secrets remain only partially revealed, and perhaps they always will. But in its refusal to fit it, has expanded the boundaries of possibility, reminding humanity that the universe is stranger than we can yet conceive, and as it vanishes it leaves behind a question more profound than any answer: what other travellers wait in the galaxy, and what mysteries will they bring when they arrive? By the closing weeks of the year, 3i Atlas drifts outward along its hyperbolic path, retreating steadily from the sun and from human reach. Its brightness diminishes with each passing night, yet astronomers remain unwilling to let it go. The object has proven itself too strange, too unique to abandon while it is still visible. Professional observatories devote precious time to long exposures, coaxing faint light from the background of stars. Amateur observers, though, fewer now persist with determination, stacking hundreds of frames to reveal a fading smear of green. Each image feels like a farewell, a final gesture of connection before the interstellar visitor slips forever into the void. The data collected in December and early January shows a steady decline in brightness overall, but still punctuated by irregular flares. Even in retreat, the comet refuses to behave predictably. These surges are weaker than before perihelion, yet they remain significant enough to distort the light curve and defy simple extrapolation. Some scientists argue that this confirms fragmentation, with separate pieces activating at different rates. Others maintain that the nucleus is intact but riddled with cavities that collapse unpredictably, releasing bursts of gas. The truth remains elusive, hidden within the haze of the coma, inaccessible to even the most powerful instruments. What is clear is that 3I Atlas continues to act as though it carries reservoirs of material alien to our expectations, substances that respond to sunlight in ways unseen in solar system comets. The chemical story deepens. Spectra obtained in the post-perihelion months reveal faint but persistent traces of unusual molecules. In addition to diatomic carbon and cyanogen, researchers detect lines suggestive of complex organic compounds. These are not evidence of life, but they are evidence of chemistry rich enough to intrigue astrobiologists. Some of the compounds could form naturally in interstellar space, where radiation and dust grains catalyze reactions over millions of years. Their presence in 3I Atlas suggests that the object has preserved and now released molecules forged far beyond our Sun. To detect them is to glimpse not just another star system, but perhaps the broader chemistry of the galaxy itself, a chemistry that might provide the seeds for planets and even life. The anti-tail remains visible longer than anyone expected. Even as the comet dims, its sunward orientation persists in images, a stubborn defiance of cometary norms. Plasma models continue to struggle with the phenomenon, and while new ideas circulate magnetic draping charge inheritance from interstellar passage, bow-shock sculpting, none resolve the anomaly completely. For many scientists, the persistence of the anti-tail is the defining mystery of 3I Atlas, the feature that best captures its alien nature. It is a reminder that even with advanced instruments and sophisticated models, some aspects of the universe remain beyond explanation. The anti-tail becomes a symbol of the unknown, pointing not just toward the sun, but toward the limits of human understanding. The comet's departure invites reflection on the 3 interstellar objects observed so far. Each has rewritten expectations in its own way. ʻOumuamua showed no coma, yet behaved as though pushed by invisible forces. Borisov resembled a comet, but revealed dust grains unlike any seen before. 3I Atlas combined cometary features with profound anomalies, erratic brightening alien chemistry and a sunward tail. Together they suggest that interstellar space is filled with fragments of extraordinary diversity. Each carries the fingerprint of its birthplace, the memory of its journey, and the imprint of processes far from our own star. To have seen 3 such objects in a single decade is remarkable, and it implies that more may come, each bearing new mysteries. The impact on the scientific community is already clear. Research groups that once regarded interstellar visitors as curiosities now see them as central to understanding planetary formation and galactic chemistry. Proposals for rapid response missions gain momentum. Engineers imagine spacecraft held in readiness designed to launch at short notice and intercept the next visitor before it escapes. Such missions could sample dust, directly measure plasma fields, and resolve the mysteries that telescopes cannot. The case of 3i Atlas strengthens this urgency. Remote observation has revealed only fragments of truth, leaving too much unanswered. The next interstellar object, some argue, must not be allowed to pass unvisited. For the public, the story of 3i Atlas takes on a quieter tone as it fades. The excitement of perihelion survival and the spectacle of its green glow give way to reflection. Articles describe it as a ghost retreating into darkness, a traveller from another star that paused only briefly in our skies. Amateur astronomers speak of the privilege of having followed its passage, even if only through faint images. The comet becomes a story of impermanence, a reminder that beauty and wonder often arrive unexpectedly and depart just as swiftly. In its fading, it carries the weight of mystery more deeply than in its brilliance. Speculation, however, does not fade. Some continue to wonder whether the comet's plasma behavior hints at levels of organization that mimic life, not biological, but physical patterns of self-organization that blur categories. Others suggest that fragments like 3i Atlas may carry the complex chemistry that seeds young worlds, scattering the building blocks of life across the galaxy. Still others imagine that each interstellar visitor is a messenger, not by design but by existence, carrying with it the evidence that planetary systems are not closed but interconnected through exchange. None of these ideas can be proven by the data at hand, yet the comet invites such speculation, for its very anomalies demand imagination. As the new year begins, 3i Atlas is barely visible, a faint smudge detectable only by large observatories. Its hyperbolic path ensures that it will not return. Once gone, it is gone forever. Astronomers calculate its trajectory outward, a line that carries it back into interstellar space, destined to wander for billions of years, perhaps crossing paths with another star system in the distant future. For now, it leaves our solar system enriched with questions carrying secrets that remain unspoken. It has offered only hints, fragments of its story glimpsed through light curves, spectra and images. The rest remains locked within its alien nucleus, carried outward beyond reach. And yet its impact endures. The months of observation have altered understanding, reminding humanity that the galaxy is not static, but dynamic, filled with fragments that cross boundaries and bring with them the unknown. The comet has shown that interstellar visitors are not curiosities but windows into other worlds, archives of chemistry and physics written far beyond our sun. Its departure leaves a void, but it also leaves a legacy, a deeper awareness of mystery, a readiness for the next arrival, and a reminder that the universe is always larger, stranger, and more surprising than imagination allows. As 3i Atlas recedes into the dark, its green glow fading into memory, humanity watches and wonders. What worlds gave birth to this fragment? What forces shaped its chemistry and plasma? What secrets will never be known? The answers vanish with the comet carried into silence. But the questions remain, and perhaps they are the greater gift. For questions keep humanity looking outward, keep telescopes searching, keep imaginations alive. The traveller departs, but the mystery endures. By January, the retreat of 3i Atlas is undeniable. It is no longer a prominent object, even in the deepest stacked exposures from amateur telescopes. Only professional observatories with sensitive instruments and long integrations continue to trace its fading presence. The once vibrant green coma is now subdued, diluted by distance, its fluorescence weaker with every passing day. Yet even in decline, the interstellar traveller remains an object of fascination, for its anomalies do not disappear with brightness. The light curve still shows irregularities, the anti-tail persists faintly, and spectral signatures continue to suggest chemistry alien to the solar system. In its silence, the comet continues to whisper questions that remain unanswered. The data accumulated over its passage is now immense, a patchwork of light curves, spectra images and models collected by professionals and amateurs alike. Scientists begin the long work of synthesis, comparing observations across time and geography. Patterns emerge: the first surge of brightness as it crossed the orbit of Jupiter, the dramatic leap when it passed within 2 astronomical units, the erratic pulses leading to perihelion, the sudden intensification during conjunction, and the irregular flares afterward. Each phase reveals behavior inconsistent with models derived from solar system comets. Together they confirm that 3 Atlas is not merely another comet, but a representative of something different, something alien. Theories now turn to origin. One line of thought holds that the object was born in the icy outskirts of a distant planetary system, ejected billions of years ago by gravitational encounters with giant planets. Another suggests it could be the remnant of a planetary collision, a shard carrying chemistry altered by cataclysm. More radical ideas propose that it may have formed in the dense molecular clouds between stars, preserving compounds from before the birth of suns themselves. None of these theories can be proven, but all are supported in part by the comet's unusual chemistry, its erratic activity, and its alien persistence of a sunward tail. What unites the theories is the recognition that the object carries with it a history far older and more distant than our own solar system. The comet's plasma environment remains one of the most tantalizing mysteries. Dusty plasma is known on Earth to self-organize into patterns resembling networks and filament structures that appear ordered in ways that hint at complexity beyond simple physics. The anti-tail of 3I Atlas oriented persistently toward the Sun may be an expression of such order on astronomical scales. Models of solar wind and radiation pressure fail to explain the geometry fully. Some researchers speculate that the comet's rapid velocity and unique charge distribution, shaped during its long interstellar voyage, produced a plasma regime never before encountered. To study it is to confront the possibility that the behavior of matter in space is more varied and strange than terrestrial experiments suggest. Public fascination has not entirely faded even as the comet itself slips beyond easy observation. For months its story dominated news reports and social media, weaving together themes of survival, alien chemistry, and cosmic mystery. Now it lingers as a quieter narrative, the tale of a visitor from beyond that survived fire and shadow, revealed its strangeness, and then departed. Enthusiasts compile timelines of its passage, sharing images that document its evolution, from faint speck to blazing green apparition to fading ghost. For many, 3I Atlas becomes a symbol of impermanence, a reminder that beauty and wonder appear briefly, and then are gone, leaving only memory and unanswered questions. Within the scientific community, its legacy is more concrete. The comet has strengthened the case for new survey telescopes designed to detect faint, fast-moving objects, ensuring that future interstellar visitors will not go unnoticed. It has fueled proposals for rapid response missions, spacecraft capable of intercepting such bodies before they vanish. And it has inspired new models of planetary formation, interstellar chemistry, and plasma dynamics. Even in departure, 3 Atlas continues to shape the future of science, pushing imagination toward possibilities that only months ago seemed remote. Comparisons with its predecessors sharpened further. ʻOumuamua, with its cigar-like shape and unexplained acceleration, sparked debates that continue to this day. Borisov cometary, yet unusual, provided the first confirmation that interstellar objects can resemble our comets while carrying differences. 3I Atlas expands the spectrum of possibilities again, with anomalies too numerous to ignore erratic brightening alien chemistry, persistent anti-tail, Together the three form a sequence that speaks of diversity without limit, each one a messenger from a different environment, each carrying the imprint of distant histories. If three objects can differ so radically, then what might the next bring? The anticipation is palpable, and the search for future visitors has already intensified. Speculation flourishes alongside data. Some imagine that interstellar comets like 3I Atlas act as couriers carrying complex molecules across the galaxy and seeding young systems with the ingredients for life. Others ponder whether its plasma environment, with its self-organizing patterns, hints at deeper levels of complexity, perhaps even a form of matter that blurs the line between inert and living. These ideas remain conjectural, but they are not dismissed entirely, for the comet's behavior has shown that the universe does not always conform to expectations. To consider radical possibilities is not to abandon science, but to recognize that the cosmos may hold processes beyond current understanding. As the weeks pass, the comet's departure becomes final. It fades below the reach of all but the largest telescopes, and eventually even those lose it. The last images show only a faint smear of light against the background of stars, its green glow gone, its anti-tail barely visible. Soon it will be indistinguishable from the countless other fragments drifting between the stars, another wanderer in the vast darkness of the galaxy. Yet unlike most, this one has left a trace in human memory, a record of data and wonder that will not vanish. The legacy of 3 Atlas is not resolution but mystery. It has raised questions rather than answered them, challenged models rather than confirmed them. It has shown that interstellar visitors are not rare curiosities but profound opportunities, windows into other systems, other histories, other chemistries. It has left behind a sense of humility, a reminder that the universe is larger, stranger and more complex than the frameworks built to contain it. As it departs, it carries its secrets with it, leaving humanity with nothing but light, curves, spectra images, and the enduring sense of wonder that comes from glimpsing the unknown. In the silence of its retreat, the interstellar traveller becomes a story told in whispers. A body that crossed the void for billions of years passed through the solar system in a matter of months, revealed anomalies beyond explanation, and then vanished again into the night. Its presence has been brief, but its impact endures. The galaxy is full of such travellers unseen, until chance and timing bring them near. Each carries its own mysteries, and each reminds humanity of its place in a cosmos that remains unfathomable. 3I Atlas is gone, but the questions it left behind are alive, waiting for the next visitor to awaken them again.